I'm Dr. S. Prisfelcia, School of Life Sciences, Crescent Institute of Science and Technology. Today I'm going to talk about bioremediation of toxic pollutants, an approach using microorganisms and nanoparticles. The very essence of life. This surrounds us in abundance on our planet. Yet, despite its vastness, our ability to access clean, usable water is remarkably limited. Out of all the water on the earth, less than 3% is fresh water, and a mere fraction of this is available for our daily needs. The rest of it is locked in glaciers and ice caps. It's a sobering realization highlighting the preciousness of water. We often take it for granted. Scarcity is only the part of the challenge. The greatest challenge is pollution. The quality of water is increasingly compromised. Why? It's due to pollution. Pollution disrupts the delicate balance of the aquatic ecosystem. So how does the water get polluted? From direct industrial discharge or more insidious sources, like every time we wash our car or apply non-chemicals, every drop of rain that washes the pollutant from the road into nearby rivers contribute to this problem. The contaminated water doesn't just harm aquatic life, it also poses serious risk to human health as well. For this study, what are the pollutants which are let out from the industries? We see major industries generate pollutants in form of phenol, chlorinated phenols, heavy metal, coloring chemicals, nitrates, phosphates and sulfates, etc. The use of these pollutants have been increasing in the revenue generating industries, and it will be increasing even more. So the effluents which use these, the industries which use these chemicals let out the effluents into good water, which in turn contaminates the water, leading to serious health issues to humans as well as the environment. Which use toxic pollutants. I've mentioned very few industries like petrochemical, plastic, pharmaceutical, leather industry, agriculture, coal refining industry, and there are many more. And some of the toxic pollutants nomenclature which I have shown over here are phenol, monochlorophenol, dichlorophenol, trichlorophenol. All these have benzene ring with OH group. These are for example, and they also have a chlorine atom. As the number of chlorine atom increases, the toxicity also increases. Has also taken measures, and it has given permissible level for each of the compounds. For example, in case of phenol and chlorinated phenol, the level which has to be present should be around 1 to 5 mg per liter in wastewater and less than 0.1 μg per ml for potable water. But when we see the reports, we can see that the amount present is way higher than the permissible level, and hence remediation or treatment of water is very essential. Why these pollutants should be below the permissible level or it has to be treated? It's because of its toxicity. For example, most of the pollutants are carcinogenic and mutagenic in nature, and few of them are priority pollutants, and they have been banned in so many industries such as lead, mercury, chromium. But still, do you think it has been completely banned by the industry? No, it's still in use, but they have reduced the usage of this chemicals. Why are these chemicals still being used? Because there might be lack of suitable alternative, or because of cost consideration or resistance to change. There are also other carcinogenic chemicals like DDT, toxicity or other volatile organic compounds which are still being used in few of the industry. And the toxicity, what are the toxicity? How toxic are these chemicals to our body? It will irritate our sensory organs. It will cause irregular breathing, muscle weakness, tremors, and loss of coordination. Sometimes you will have convulsions and coma and respiratory arrest at lethal dosages. And some of them will be anorexia, weight loss, gastrointestinal irritation, and blood and liver problems, and dermal inflammation and necrosis, and cardiac problems. Hence, because of all these toxicity, careful consideration has to be given for remediation of these compounds. Various methods used for remediation till date, they are chemical method, physical method, biological method, and nanotechnology. In case of chemical or physical methods like flocculation, coagulation, ion exchange, etc., the contaminants will get aggregated or form insoluble precipitate. And in case of physical method, it can be effectively removed or separated based on size, charge, and other properties. But still, for complete remediation, further treatment of these compounds is very much required. In case of biological method, we use microorganisms like bacteria, fungi, or living organisms like plants. These organisms, they transform the contaminants that take place as a part of the metabolic process. They enzymatically attack the pollutant and convert it into non-toxic compound. But the major drawback of biological processes, it's a time-taking process. Not all compounds are biodegradable. Some may be toxic to the organism. But the advantage pertaining to this technique is the safety of the environment. Harmless product will be produced like carbon dioxide, water, and cell biomass. At times, complete destruction of target pollutants, and also this is a very less expensive method. The next method is the nanotechnology, where we use nanoparticles for remediation. It is one of the most promising area, but for high efficiency, combination of nanoparticles with physical, chemical, or biological method makes them a versatile tool for environmental remediation. Have an effective treatment method, remediation using an integrated approach will be most helpful. So what are the uses using the integrated approach? In case of nanobioremediation, for example, if we take 2,4,6 trichlorophenol, one of the toxic pollutants, the nanoparticle can effectively transform this 2,4,6 trichlorophenol to phenol. And eventually, the microorganisms can easily degrade the simpler compound, which is the phenol. But what will happen if 2,4,6 trichlorophenol is exposed to microorganism? Due to the presence of 3 chlorine atom, the organism's ability to degrade will be hindered. So, hybrid technology can be used for remediation in order to get best results. Hybrid technology, what are the emerging trends and future directions? How the research can be developed is by development of a novel nanomaterial, by advanced sensing technology, and integrated bioremediation strategies. These will offer innovative and sustainable solutions for addressing toxic pollutant in the environment. These techniques will harness the power of biological process to degrade, and it will also be a cost-effective solution, tailored pollutant removal, as it will produce a non-toxic metabolite which will not be harmful to the environment. So these are the potential outcomes when using a hybrid system for environmental problems such as remediation